This is part 3. Okay. We are looking at question number 3. We need to sketch. Please take note. We are not drawing, we are sketching the change in the height of the water in the following containers. Okay. The first two, right, is actually this is water poured into, this is water flowing out from the container. Okay. In other words, the tap must be here. Okay. So you fill up from here, and here the container is full with water, and maybe there's a leakage here. Okay. So now if you have to take note, right, volume, right, is actually, right, base area times height. Now this is a very important consideration. So what's the height equals to? The volume over the base area. The bigger the base area, okay, the slower will be the change in the height. Okay, not? The smaller the base area, the faster the height will increase or decrease. Now, using this simple illustration, right, or simple conceptual understanding, if we pour water, initially the base area here is very small. See not? And it got larger and larger. Am I right? So for when it's small, right, you can fill faster. Okay. So now is it going to be? We know it's not going to be a straight line from here to the hemisphere. Okay, to the brim of the hemisphere. So we know that it cannot be a straight line. Now our question is it a concave or is it a convex? Okay. I'll let you think about it for a while. Okay, the answer is going to be this direction, what we call a convex. Okay, because initially the base area is very small, so it increases fast. Okay, let me just withdraw for you again. Maybe we need some space. Okay. Okay, after that it will be very slow. So initially very fast, and then once you reach to the brim, it got filled up very slowly. Okay. There you are. Now here will correspond to here. Okay, to the brim of the hemisphere. Now after that, right? Okay. The base area will get smaller again. Smaller, smaller, smaller. So we know that it's going to be something like this. Okay. Now if let's say water is flowing out, okay, again, so it will flow out here very fast, down. Okay, after that it will be like that. Okay, and somewhere towards the bottom of this hemisphere is going to be very fast. You'll notice that this is just a reflection. Am I right? It makes sense, right? Okay, for the next container, again, for part D, part 1, we are actually filling up. And here, let's see there's a tap here. We open the tap. Here there's water leaking. Okay. Now, again, if you to fill up the water, initially will be very fast. Okay. Very fast. After that, it will get slow. Okay, because as the area, the base area increase, you can see, right? Okay, now after that, from here to here, it's going to be a constant, because, sorry, okay, because the base area doesn't change. You see, not the base area is still the same. This is the prism here. So in similar fashion, if water is flowing out, this will be this direction. Okay. And then here, after that, it will be very slow, and then it will be very fast. Again, it is a mirror reflection. Okay. Now this concludes my teaching for part 3. Please take note that after that, right, if you take note, I give you a summary of the distance time and the speed time. Okay. Please read this one. This is a very good understanding. Okay. For speed time graph, the area under the graph will be the distance travel. Can I just ask, for speed time graph, what is the area under the graph represent? The answer is, it's not applicable. Okay? It doesn't represent anything. But for speed time graph, it represents a distance travel. Okay? Now after that, you will notice that I give you something like this. Graph in practical situation. There are actually two questions. I don't want to give you too many questions. Okay? And this one. Okay? Just to test your understanding. Okay? With that, I thank you. I see you tomorrow in the Google Meet later.